Hello, B period friends. This is a podcast to give you what you would have gotten today had we met. And basically, what we're doing is practicing in section 7.2 in the AP Stats book. Reminder from the podcast you got last night that you have here a formula for the mean of a discrete random variable. Further, the mean, this mu, the Greek letter mu right here, is the expected value. They are the same thing. So if you were asked a question for expected value or the mean of a distribution, you're getting the same thing, and you're using this formula here. Looks much more complicated than it is. Very simply put, you're going to multiply each possible outcome times its probability. You get a number, and then you add all those numbers up, and that is the mean. I had a question in the morning class, do I have to divide by anything? The answer is no. Remember, every probability must be between 0 and 1. Hence, it's a decimal. And so this multiplying by the probability replaces the dividing that you would normally do when finding an average. We're really just finding an average. All right, that's all we're doing. And I'm going to hit two birds with one stone here. I am going to also cover this variance. All right, and this looks even more complicated. Oh my goodness, look at all this stuff. But it really isn't, and I'm going to show you on the calculator how to do this, and it should be pretty easy. Okay, you're going to, once you've found the mean of the standard deviation, which we'll do in the example, you have this number mu. So for each one of these now, you can see, let me do it with this. This part of the formula is simply I take this number, each x, subtract the mu that I found, it'll just be a single number, and I square that. And then I multiply it by the probability. I do that for each one of these numbers all the way up to here, and I add them up, and that is the variance. And you should remember from earlier in the year that the standard deviation is just the square root of the variance. All right, so let's look at an example. All right, so this is problem 7.24, and they're asking you to find the average, that is the mean of this distribution, also the expected value. In other words, the grades in this class go from 0 to 4. This is the percentage of the students that take it that get each one of those grades. We want to know what's the average grade in this class. In other words, above what grade would I get to be above average or below, whatever like that. So very simply, you're going to open your calculator and you are going to put each grade, and let me get over here where it's already done, each grade in L1. So this is now my x, my random variable x, which is the grade I can receive in the class, and this is the probability of x right here. All right, I'm back to a clear screen now, and I'm going to show you how to do some list operations without actually being in the list, and I hope this will make more sense to you. So before I do that, let me just remind that this is x, and this is what is in L1, and this is the probability of x, and that's what's in L2. And what I'm finding is mu. Okay, and the mu is just the sum of each x times its probability. All right, so that's what I'm doing on the calculator. So this calculator is open. I already have L1 and L2 in, and you should too. And now watch what I do. I'm going to open parenthesis. I'm going to say L1 times L2, and I'm going to store that result in L3. Okay, now when I hit enter, it shows you the values that we'll actually take, and further, the mu is just the sum of all these numbers I just put in L3. So I'm going to go second list, one left hour to math, number 5 is sum, and I'm going to sum L3. When I hit enter, so 2.78 is my mu. All right, so now I've set 2.78 as the mu. So this is the average grade in the class, and I'm going to do a second podcast to show you how to get the variance. But what I would do is jot down those calculator steps and actually sit with your calculator watching the podcast and do the steps. All right, not really complicated, just a new complicated looking formula.